So find the sampling distribution of M. Alright guys, so M. Now if you remember, was actually the maximum between the three games, yeah? So essentially it's any of these. Well, you also got 5 now because that's included. To do this, I just thought about like this. I just said, okay, so what is, first we need to construct our table. We don't know these red values yet, but we need to calculate them. What I did is firstly find the probability of getting a 3. And probability of getting a maximum value 3. Now the only way to get a maximum value 3 is from the very first combination I presented, 3 through 3. Because any other combination of 4s and 5 will automatically make that number the maximum value. Because remember, you want a maximum value between 3, 4, or 5. So this is the only possibility, which is 3 through 3. And to get this, you need to have 50% times 50% times 50% of a game. So that's why it's written like this, 0.50 to the power 3. Okay, and that gives us 0.125. Now to get 4, it's the same style. You just need to get a maximum number of 4. You need out of any game, whatever combination you have, the maximum set should be 4. So I think that's why they kind of did it for us over here, where they did M doesn't equal 5. It actually helps us for part B indirectly. So let's have a look. Besides the first game, besides the first sample with 3 through 3, the other samples, the other 7 samples, 3 plus 3 plus 1, you can actually get a maximum value of 4, because out of 3 and 4, the maximum is a 4. So what I did here, I said let probability M equals 4. You can get it this way, probability of this combination plus this plus this. And yes, to get a 3 we know is 50%. So it'd be 50% times 50% times to get 4, which is 30%. So 50 plus times 30%. And then whatever that is, multiply by 3. And then do the same for each one. This would be 30% times 50% times 50. Oh god. 50% times 30% times 30%, and all of that times 3. And to get 4 sets in every single game, it will be 30% times 30% times 30%. And then yeah, you just add up the totals, and that should give you 0.387. And to get 5, well, this is easy. You can calculate it, but there's no point. You could just realize that all probabilities add up to 1. So add up these two values, 1 minus them, and you should get 0.488. That's it.